Good morning. Today we're going to be talking about the distributive property and actually properties in general for math. And we're going to start on page 91. I have given you a page that has various different properties that we talk about in math, and I wanted you to put that onto page 91. We're going to talk just briefly about those different properties. So starting off with the zero property of multiplication, the one with the little donut. That property states, let me zoom in a little bit, that any number multiplied by 0 is equal to 0. So 5 times 0 is 0, and so forth. And then we have the identity property. The identity property is the property that has the little girl with the mirror. She's a little self-evolved. She focuses on herself, just like the identity property of addition or multiplication. And it is basically that anytime you add a 0 to a number, or you multiply a number by 1, you're going to get the same number back. So 4 times 0 is, 4 plus 0 is 4. 4 times 1 is 4. Okay, next we're going to go to the inverse property of multiplication. This states that any number multiplied by its inverse is equal to 1. So remember that a fraction, if you have 1 over 7, the inverse would be 7 over 1. You're just flipping those fractions. If you have a number 7, the inverse of that would be 1 over 7. So you would just put a 1 underneath it and then flip it. And when you multiply a number by its inverse, it's going to equal 1. Then we have the commutative property. So I'm going to move this down. This is just a review of these different properties before we really get into the distributive property itself. So the commutative property of addition and multiplication states that no matter what order the add-ins, and remember add-ins are the term we use when we're adding numbers, it's the numbers we're adding, or factors appear, they both will equal the same product. Basically, if I were to say, what is 5 plus 7, you would say 12, right? Well, if I say, what is 7 plus 5, you would say also 12. It doesn't matter if the 7 comes first or the 5 comes first, they're still going to have the same answer. Likewise, if I were to say, what's 2 times 3, you would say 6. But if I said, what is 3 times 2, you would also say 6. It's the same exact thing. So basically, it just means that it doesn't matter what order they come in, it's going to give you the same result. And actually, you can have even more than one. So if I were to say, what is 5 plus 2 plus 7, I'm going to get 5 plus 2, which is 7, plus 7, which is 14. But if I said 7 plus 5 plus 2, I'm going to get the same answer. So it doesn't matter the order, even if it's more than one. And then that brings us to our focus for today, which is the distributive property. This one where it's a little guy who's distributing out his little newspapers. And the distributive property states that multiplying a sum by a number gives the same results as multiplying each add-in by the number and then adding the products together. The outside number gets distributed to each inside number. It sounds more complicated in definition, but we're going to actually really dive into this and explore it deeper, which will make it seem to make more sense. Okay, so now we're going to go over to page 92. Your topic, once again, is going to be the distributive property. Part 1. And your essential question, it's going to be a long one today, so bear with me. How do we use the distributive property to simplify an expression? It's actually not that long. Okay. Now, a simple definition for the distributive property is this. If I have A next to parentheses B plus C, that is going to equal A times B plus A times C. So basically, you're just taking what's outside of the parentheses and you're distributing inside. So you're giving a little bit of A to the first thing in the parentheses and a little bit of A to the second thing in parentheses. So we're going to do a problem here. So for example, if I had 6 parentheses 2 plus 3, and I wanted to use the distributive property to make another expression that is the same value, I would take this 6 and I would take it inside the parentheses, and I would go to the first number inside the parentheses, the 6 times the 2. Well, class, what is 6 times 2?
12.
Okay, so 6 times 2, which would also be 12. And then I'm going to go to the second one inside the parentheses. So I would go 6 times 3. But I'm going to make sure I keep my plus in there because the plus stays the same. So do you see how I have a plus here? And I keep the plus here? Okay. So I took 6 times 3, which what you said. Oopsie daisy. Is that better? There you go. So, like I said, I've got the 6 times the 3. So what is that, class?
18.
Okay. So now I've got 12 plus 18. When I add 12 and 18 together, I get 30. So that is a way that we can solve using the distributive property or evaluate with distributive property. Otherwise, I would be taking 6 times the quantity 2 plus 5, or I said 2 plus 3. Whoopsie. And then I would say, okay, well, inside the parentheses is 2 plus 5, or 2 plus 3, which is 5. Outside the parentheses is 6, and I would multiply that. 6 times 5 equals 30. This is the order of operations way. This is the distributive property way. Now, when it's a problem like 2 plus 3, it doesn't seem like, well, why do I need to use the distributive property? I could easily multiply 6 times 5. It's actually easier. It is, but there will be times where the problem will actually be harder if you don't use the distributive property. So we need to make sure that we are using it when we can. Okay, so now what I'm going to have you do is do a little T-chart. Just a simple T-chart. And I'm going to write process and problem. And we're going to have 2 parentheses x plus 3 parentheses minus x. Okay? This is an algebra problem. It's got some variables in it. And we would want to solve this or try to evaluate it. We're going to evaluate it trying to figure out what x would be. And we're going to do that by using the distributive property. So the first thing we're going to do is we're going to use the distributive property to remove the parentheses. Okay, so to do this, I'm going to go over here, and we sometimes call this the rainbow method because you kind of make a rainbow and you do one little color, then you do one other, but just know we go to the first amount inside the parentheses, then we go to the second, and we keep the same operation. So I'm going to go 2 times x, which I can just write 2x, okay, 2 times x, then I'm going to have a plus, then I'm going to go 2 times 3. Well, 2 times 3 is what? 6. Thank you. And I'm going to keep this last part. So now I have 2x plus 6 minus x. Okay. Now we're going to do some algebra. And we did talk about this last semester. We will be talking about it quite a bit in about a unit. But I'm still going to go through the process with you. So the next thing I would do to evaluate this thing is I would combine like variables or like terms. So if I have variables, I'm going to put those variables together if they're the same variable. If I have numbers, I'm going to put those numbers together. And so to do this, let me push this up. I realize I have a 2x here, and then I have a minus x here. I'm going to just take this minus x, and I'm going to apply it to this 2x. So it's going to be like 2x minus an x. Well, what's 2x minus an x?
2.
What would I have left? I have 2 x's. I subtract 1x from it. What do I have?
1x.
1x, right? So I'm going to just subtract the x here. So I'm going to have an x. And I could have a 1x, but 1x and x are the same thing. It's one of them. And then I'm going to drop my plus, and I've got my 6. So I just got rid of this extra x. I applied it here, put it together, and then I'm left with 1x. So 2x minus 1x is 1x left. Then, this is where it gets a little tricky. We're going to isolate the variable. To isolate the variable means to get the variable alone. Okay? So to isolate the variable, you do the inverse operation. The opposite operation. Well, in this case, what is the opposite of adding an x? Or, I'm sorry, what is the opposite of adding 6? What would be the opposite operation of adding 6, Michaela?
Subtraction.
Subtracting what? So what's the opposite of adding 6?
Subtracting 6 from the x.
Subtracting 6. Okay, so I would have x plus 6 minus 6. Those cross each other out. Okay, but the thing is, with an algebra problem, is whatever you do on the right side, you have to do on the left. Or vice versa. Whatever you do on the left, you have to do on the right. Okay, so either way that works. So if I do a minus 6 on this side, I need to do what on this side? If I minus the 6 on this side of the equal sign, that's the left. Whatever I do on the left, I got to do on the right. So what do I do on the right? Minus what?
6.
Good. These are crossed out, so now I'm left with x equals negative 6. You've now solved a complicated algebra problem using the distributive property and isolating the variable and finding the inverse operation. We'll be doing this quite a bit, but just keep in mind with the distributive property, you're doing this rainbow where you go inside or outside to inside, and keep the operation. Have a great day, guys.